The first thing that you do when you look at one of these is to look on the left side and see, are the x values going up by 1, going up by some other number that's a constant, or going up by different numbers? In this case, each one of these is going up by 4. Okay. Remember, when we do one of these, we're talking about a sequence. We're talking about a sequence that has numbers that run, from the first number, second number, third number, fourth number. So if this list is going by 4s, this is an incomplete list of the sequence. Between here and here, there's also a 5, a 6, a 7. Then there's 8, then there's 9, 10, 11. You don't need all of them to do the job, but you need to be aware that they're missing. Over here, when you look, the first thing you're looking for is to see whether these numbers go up by a common difference. In other words, are they going up by addition? And in each one of these cases, they are. They're going up by 12. Okay? So for every 4 that the x goes up, the y goes up 12. That your sequence is going up by addition. That makes it a linear function. Right? It is an arithmetic sequence and a linear function. There is a common difference, but let's look for a minute at what that common difference is. Okay. If you look at a graph, you start to figure out, well, okay, where is 4? 1, 2, 3, 4, and 7. 1, 2, 3, 4, 5, 6, 7. That's the point 4, 7. Okay. Where is 8? 1, 2, 3, 4, 1, 2, 19. If you take a ruler or a straight edge and you run your line from here to here, notice what happens. Notice that for every 1 you go over on the x-axis, you go up 3 on the y-axis. Over 1, up 3. Over 1, up 3. Over 1, up 1, 2, 3. I guess that's 19. Okay? Do you guys see what I'm doing here? Okay. Those are the missing numbers over here. When you're learning to do slope, one of the things that you learn is that it doesn't matter which 2 numbers you take, it's the ratio of the difference in y compared to the difference in x, right? So if I go from here all the way to here, whatever these numbers are, this difference in y here and this difference in x over here, whatever those numbers are, they're going to have the same ratio as this. In other words, if I divide this number by this number, it will be the same as if I divided this number by this number. That's slope. In order to find that here, you have to take the difference in these values, which is 12, and divide it by the difference in these values, which is 4, and that gives you 3. Right? That right there is your common difference. It's the slope of the line that this linear function creates, right over here. And now you can use any one of these numbers to create your equation. F of x is going to equal any one of these numbers right here, pick one, whatever one it is, it's indexed, right? So if you pick this one, it's indexed with 12. If you pick 19, it's indexed with 8. Right? This is the 8th number in the sequence. Okay? Plus, because it's an arithmetic sequence, 3, because that's the common difference, times whatever term we're looking for minus whatever term we're using here. Okay? So if I'm looking for the x number in the sequence, I can take any number that I know and add how many 3's to it? Well, these many 3's minus these many 3's. That's how many I have to add, which turns out to be multiplication. So pick any number here that you want. Let's say f of x is equal to 7 plus 3 times x minus 4. Okay? And that's a perfectly good equation for this sequence. No matter which one of these you pick, after you've done this, you can do a little bit of arithmetic and say, well, this is 7 plus 3x minus 12, and that's 3x minus 5, and it's always going to reduce to this. But this isn't the only right answer. This is a perfectly good answer if that's what you gave. Any one of these will do. Does anyone have a question about that? Yes?
So would that be like the same as like fx equals -2 plus 3 5 minus 1?
Right? You're talking about this? F of x is equal to 2 plus 3 in
Negative 2 plus 3.
-2 plus 3. Oh, times x minus 1? Like,
Yeah, or n minus 1.
like that?
Yeah.
I don't know. Let's find out. If I multiply -2 plus 3x minus 3, right? That's the distributive property. And then 3x minus 5. Yeah, that's the same. Why is that the same? Well, look. If I follow this line all the way down, when x is equal to 0, y is equal to 1, 2, 3, 4, 5. -5. Okay? So this is 0, comma, -5. If x is equal to 1, y is equal to -2. Right? So what you're doing is using this point as your reference. You're saying, okay, I'm picking the first term in the sequence, right? A1. It's -2. And so I'm going to multiply, I'm going to add to that the common difference times the number of the term I'm looking for minus the index of the term I used.
Yeah, that's what I was using. When you first add the common difference and subtract almost everything.
It's fine, right? You used, when you did this, you figured out what the first term was and put a 1 over here. What I'm showing you is you don't have to do that. It's fine if you do. But you can use any one of these. If I use 20 and 55, f of x is equal to 55 plus 3 times x minus 20. Do the arithmetic. 55 plus 3x minus 60. It's equal to 3x minus 5. It's going to work that way every time.
So just any two numbers you want those to work?
as long as you do it right, yeah, you can pick any one of the f of x numbers and use it here, and then use its index, its x value over here, when you subtract x minus something. Okay? All right. So here we are again. This time there's a difference of 1 in your x values. They go up by 1. So there are no missing terms here. Right? From 4 to 8, we've got them all. The fourth one is 24, and the next one is 48. Well, if we were adding 24, that would be okay, but then if I add 24 to 48, I don't get 96. So the second thing we check for is multiplication. Am I multiplying anything? 24 times 2 is 48. 48 times 2 is 96. 96 times 2 is 192, and 192 times 2 is 384. So this is a geometric sequence which makes it an exponential function. It's got a common ratio instead of a common difference. And that common ratio is 2. Okay? Now, if it's an exponential function, you're going to be looking for a variable in the exponent. Just like when it's a linear function, you know that there's going to be a line as the graph. When it is an exponential function, there's going to be a variable in the exponent. So what does that look like? Well, we've talked about this as well. You can take any one of these terms and then multiply it by the ratio raised to the x minus this number power. Why is that? Well, there's some starting point up here, and you keep multiplying by 2 over and over again. Multiplying over and over again is an exponent. That's what exponents are. Here, whatever number we pick here, well, that's already been multiplied by 2. Right? It's some number, right, f of 0, some starting point, that got multiplied by 2 6 times already. If I want to know the 7th one, then I have to take this one and multiply it by 2, not 7 times, but 7 minus the 6 that have already happened. If I want the 8th one, I have to take this number and multiply it by 2. How many times? Well, not 8 times, but 8 minus the 6 that have already happened. So, in this sense, right, one of the possible answers here would be 96 times 2 raised to the x minus 6 power. Okay. You can pick any one of these. Yeah. Right. What else could I pick? I could pick 384 times 2 to the x minus 8 power. Are these the same thing? Yeah, they are. How do I know? Well, take a look. Right. Or let's just work with this one here. 384, that's 96 times 2 times 2, right? And then 2 to the x minus 8, okay? So this number here is the same as this number here. Are we okay with that? Okay. If I'm multiplying this by 2 to the x minus 8, this is 2 to the first power, this is the 2 to the first power. If I'm multiplying and I have the same base number, I can add the exponents. So that makes this 96 times 2 to the x minus 8, x minus 8 plus 1 power. And when you simplify that, that's 96 times 2 to the x minus 6. Okay. In fact, let's see, 96 is, this is 3 times 2 is 6, times 2 is 12, times 2 is 24, times 2 is 48, it's starting to look familiar up here, times 2 is 96. So if I take this number right here and break it out into its prime factors, this is 3 times 2 to the x minus 6, right? X minus 5, x minus 4, x minus 3, x minus 2, x minus 1 power. Does that look right? Let's just do it. 1, 2, 3, 4, 5. So this is 2 to the x minus 1. Some of you actually thought this all the way through and wrote this. And that's right too. Okay. All of those are good answers. Right. Looking at the next one. There's a story here. There's a pool. It had 100 gallons of water in it at the beginning of the day. So before we started draining anything at all, it had 100 gallons of water. After 1 minute of draining, it had 2 gallons less, which would be 98. After 2 minutes of draining, it had 2 gallons less. After 3 minutes of draining, it had 2 gallons less. That's enough for us to look at and say, you know, this is a linear function. There is a common difference here. The common difference is -2. And the formula for this, or the equation for this, I started out with 100 gallons. And every time a minute goes by, I'm subtracting 2 gallons. And that's the equation. Okay. Again, you can use any one of these that you want, right, and put it into the other form that we were talking about. But this is the story. I started out with 100 gallons. 2 gallons every minute came out when I drained it.